G'day everyone, how's it going? Today what I'm going to do is another PDS and SDS review. So I'm going to take, in this case, an industrial gear oil and evaluate the publicly available information. Now hopefully this is a little bit in it for everyone. So if you're interested in the automotive side of the business, then obviously some of this information will be relevant to you because industrial gear oils and automotive gear oils do share some similarities. If you're from the industrial world, then gear drives are a widely enough used application that hopefully it is relevant to you as well. Now I'm going to pick a random industrial gear oil that I've never used or seen in service before. So I've picked Castrol OptiGear BM, which I had seen nothing about until about an hour ago when I opened my Chrome tabs. I'm going to be going on this journey with you, and you guys can see my thought process. The other thing I'm going to do is a little bit of a critique as well of what information is available and how that's communicated. So one of the things that I've started doing in my consulting work is actually advising companies on how to better communicate their advantages, the performance profiles and things like that. Because at the moment, when you read the PDSs for many products, they're very unclear. And I think it doesn't do the consumer any favors because realistically, they have absolutely no idea what they're buying. And I think that is in part responsible for consumer behavior where people tend to buy based on price. And it's not their fault. It's because the lubricant suppliers are not giving them the information to be able to make a differentiated decision. So anyway, that's me getting off my high horse for the moment. Let's get into it. All right, so I picked Castrol OptiGear BM, as I mentioned. As usual, try and go direct to the manufacturer's website. So anything with castrol.com on it. The reason is because if you go to your local distributor website, maybe they have outdated information. So that's why I always suggest doing that. Now, Castrol actually has a really good web portal for this. You can go in and you can refine your search based on, for example, the country or the region that you're in. That can be really important because often there are regional variations in things like additives, right? The additives supply chain, as we went through in the interview, is so vast, and so is the base oil supply chain, that realistically, some products can have slight differences in performance when you go across the regions. For the industrial products, this tends to be less the case. We see it a lot in automotive. So I would be comfortable with most of the industrial products in selecting any random country, and it's most likely that the product will be the same. Now, I typically pick Germany. Why? German regulations just seem to be a little bit tighter, and often when you go to the SDS, the German SDS gives you a little bit more information than any other countries. And the other advantage is that the German is also available in English generally. That's a handy thing to have. Now I'm going to pick OptiGear BM 220, 320, it doesn't really matter. They're like standard industrial gear oil viscosity grades. The additive package is probably no different between them. So if we go along, that's the SDS. Let's go along to the PDS first to try and tease out a little bit, what exactly are we buying? So the things that I would want to look for are, firstly, is it a mineral oil or a synthetic? Secondly, especially with gear oils, you want to see, can it be used in worm gear drives? Because often there's an incompatibility between the EP additive and the yellow metals in a worm gear drive. And a little bit about what differentiates the product from anything else. So let's see the information that Castrol's giving us. All right, so Castrol OptiGear TM BM. Castrol OptiGear, I guess TM must be trademark. Maybe they just forgot to superscript it. All right, Castrol OptiGear BM are solid-free high-performance gear oils containing the additive combination Microflux Trans TM. Okay, I'm guessing that the TM is again a trademark that they haven't superscripted. All right. So, first of all, it's a solid-free gear oil. Why is that important and why do we need to know that? Some gear oils may contain, let's say, anti-friction additives or anti-wear additives, you might call them. As an example, solid graphite particles or solid molybdate. So, by saying it's a solid-free, it's giving you an indication of how some of the additive packages work. All right, it's designed to reduce wear caused by surface fatigue, pitting, spalling, scuffing, or scoring. Okay, so they've thrown the whole basket of different gear tooth failure mechanisms there. And then it's going to describe the specific technology, which is a acronym within an acronym. So Microflux Trans is called MFT, but within MFT, The T stands for trans, which stands for triple action non-sacrificial surface engineering. Now, that is a mouthful. Wow. Okay, that's very unclear. But what does it do? It improves friction surfaces to the extent not possible, blah, 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 with traditional EP. Okay, it's a polarized MFT, so it works like a standard anti-wear or, let's say, a surface acting additive, right? It's polar, it's attracted to metal surfaces, and it creates a passive film on friction surfaces. Okay, a resistant protective layer, under severe load, it's activated, so that is describing an EP additive, and it diffuses into the surfaces. Okay, so it's a little bit more reactive than maybe an anti-wear additive, so it's describing EP at the moment. Under severe load, it's activated, diffuses into the surfaces, initiating an improvement of their friction characteristics through plastic deformation. Okay. This is an interesting marketing strategy. The reason why it's interesting, maybe I should explain that a little bit. The reason why it's interesting is because in general, when we talk about gears and the failure modes of gear teeth, plastic deformation is a bad thing, right? Gear teeth fail because of plastic deformation. If anyone, maybe I should draw this out just very quickly. Okay, you would have probably seen a stress-strain curve for metals. So generally what happens is that we can elastically deform a metal. So if we take a metal bar and we stretch it, the stress is a function of the force that I'm pulling on each side and the cross-sectional area. So I'm inducing a stress within the metal and it is elongating by a certain amount of strain. Now, generally what most metals do is they have this kind of straight line behavior, which is elastically deforming something. And then it reaches a limit and it begins to plastically deform. Now, if I let go of all the stress at this point here, then it is going to reduce back in size, but not back to its original shape. So we have now deformed it beyond its capability, and it's not going to snap back to its original configuration. So that's plastic deformation in a nutshell. Why that's really important in gears is because when we talk about two surfaces that are sliding past each other, you need to plastically deform the surface in order to cause a fatigue failure. If you looked at the surface of two gear teeth that are meshing together, right, at a micro scale, remember, the surface finish is not perfect, right? So I'm going to have peaks and troughs and all that kind of stuff. Now, these two surfaces are moving relative to each other. So one of the teeth is, especially in the sliding contact zone, one of them is moving relative to the other. Now, when these two peaks come into contact with each other, if they can elastically deform past each other, so there's going to be some amount of movement, then they continue on their merry way. Where you get into problems is when plastic deformation occurs. So what you would get, I'm not going to be able to do this very well. Hang on, let's see if I can. Is that in order to bend past each other, you get a deformation. That's a terrible drawing. But you get an actual plastic deformation which permanently changes the shape of that peak and eventually leads to a fatigue failure where we get a removal of some of the material. And if we get removal of the material so that the two can go past each other, then the fragment which is broken off because of plastic deformation now becomes a wear particle and starts circulating through our system. So in general, for where we don't want plastic deformation, and that's why Castrol's choice of words in their marketing material is a little bit interesting, especially when reading down the document. I don't think they adequately explain why plastic deformation is a good thing. All right, let's continue reading on. So the organic reaction products become a component of the tribopolymer system. Okay, whatever. Long chain compounds with excellent lubricity and adhesion. That sounds like a friction modifier. Load carrying area is improved. Hydrodynamic lubrication film is easy to maintain. Okay. Now this is interesting. So this unique physical chemical reaction is Castrol surface engineering and achieves a non-sacrificial micro smoothing of the friction surfaces. And then they don't really go on to explain how that happens. So generally, when we smooth out a surface, we need to abrade it. So think about using sandpaper to make a surface smooth, right? You use finer and finer sandpaper grains to try and eventually smooth out the surface finish. And eventually you'll go to something like a polishing paste, right? Now, when you're using a polishing paste, you're still removing small amounts of material. So if Castrol thinks that they have found a way to smooth a surface without sacrificing any of the actual material, then I would really like to understand how that happens. Right. All right, now let's go on to the application part. So like we said before, we want to know usually whether it can be used in worm gears, and it says yes. So that suggests an EP system that is not extremely reactive to yellow metals. So usually, there are some sulfur-based EP additives which would react with worm gear drives. This appears not to be the case in this product. All right, advantages. So this is one area where I have a criticism, not just of Castrol, not Castrol specific, but across the entire industry. When you look at the advantages listed here, extended lifetime of machine elements, full load operation within shortest time, lower maintenance and labor cost, lower cost for lubricant and waste oil disposal, energy savings, product consolidation, reduction of noise. I could go on to basically any, whether it's Mobil, whether it's Shell, whether it's Kluber even, whoever. And the advantages are almost identical for every single product. I would be willing to bet that if I went into Castrol's website and opened up a PDS for a synthetic product, that the advantages would all be exactly the same as, well, actually, I don't know if it's actually mentioned that this is a mineral. Yeah, I have no idea what the base oil is yet, actually. So maybe this is a synthetic, who knows? But generally, all the advantages are very generic, and that kind of hurts the consumer, because how am I supposed to choose between this and, first of all, any other product that's on the general market? But also, how do I choose between this and the other choices within Castrol's gear oil range? Right. All right, typical physical characteristics. So when you look at this, some of this information is going to be useful, some is not, right? Viscosity group, okay, they have a range of viscosities. The AGMA lubricant number is basically another viscosity classification system, which is done by the American Gear Manufacturers Association. Density, kinematic viscosities, okay. Viscosity index is an interesting one, especially for our people who are more familiar with the automotive side of the business. You're probably looking at these numbers thinking like, wow, that's really low. These must be terrible and poor quality lubricants, especially when you've got numbers that are in the 90s. Now, just to remember, in the industrial space, especially with enclosed gear sets, these products are going to be spending probably 95 to 99% of their lifetimes at a single operating temperature. Often they're indoors, so they're not exposed to the elements. They're in an enclosed gear set, and they're just turning at a constant temperature and load. That means that the viscosity index for a product is not particularly important, right? So we're not going through those stop-start cycles that you would in a vehicle. And so the viscosity index actually becomes a less important number. Now, this VI, which is quite low, is suggestive of maybe a group 1 or even a naphthenic base oil package. So although they haven't said mineral oil anywhere up here, I don't think, that suggests it is probably either mineral group 1 or a naphthenic mineral oil. All right, then you got Flashpoint, Pourpoint, copper corrosion tests. You wouldn't expect anything less than a 1A or a 1B because it is sort of newish oil, right? It hasn't really been used. Rust test, it's all passes. And then you've got some details on FZG test procedure, FVA micropitting, SRV test. Now, these, to me, are now table stakes for gear oils. If the FZG test procedure A8.3/90, which is also DIN 51354, basically every gear oil on the market these days will show a 12. Same with the micropitting test. Failure load stage 10. I'll probably have to talk a little bit more about this specific test in the future. Most of the time, you're looking for failure load stage greater than 10 and GFT classification high. And you'll see that on most mineral and synthetic gear oils. So again, that's not really giving you any differentiation between this product and any other. All right, what would I want to know beyond this? Again, I want to know a little bit more about what this MFT technology is, because they make a big deal of it, right? It's in the headline, gear oils with MFT. And then they spend most of the description talking about this MFT product without really explaining exactly how it works. So let's go across to the SDS to see if there is anything in the composition. Remember, they don't have to reveal everything in the composition. So let's just see if there's anything that we can find in here which might give us an indication as to what this product might be and therefore how it might work. All right, so what we have in the ingredients, highly refined mineral oil and additives. All right, so that's probably a group 1 then. Again, right, group 1, not necessarily a bad thing. In the automotive world, we kind of poo-poo group 1 oils, but in industrial gear oils, I have absolutely no problem with them doing that. Okay, within the additive pack, Phosphoridithiol, I can't pronounce that. That's effectively ZDDP there, anti-wear additive. Sulfonic acids, calcium salts. Okay, so that's a calcium-based detergent, right? So we've covered this before where we talked about over-based calcium sulfonates. Maleic anhydride is a really common component in a lot of corrosion inhibitors and dispersants, so that doesn't really tell us anything there. This one is a little bit interesting though. Reaction product of an ammonium molybdate. Molybdate and a diethoxylated alkyl amine. My guess would be that is some kind of corrosion inhibitor additive, although it could be the MFT additive that we're talking about. The ammonium molybdates I have seen used as corrosion inhibitors before, like the salt of an ammonium ion with a molybdate ion, that is. And so I have seen them used as corrosion inhibitors. This C12 to C24 diethoxylated alkyl amine may be the friction modifier. It might be a friction modifier. So this whole, what would that kind of look like? Let me see if I could draw out potentially what that. All right. So with the ammonium molybdate, let's see if I can get this right. So what that kind of looks like is you've got moly and sulfur. It's an ion that looks like, I can never get this. It looks something like this, I think. And it has an overall charge of 2-. So if you added 2- there, and then the ammoniums look like this. And then there's an R4 because it's ammonium, and that has an overall charge of +. So you've got to imagine 2 of those ammonium ions. Then, what does the rest of the molecule look like? That's the alkyl amine. So from memory, that is like a carbon chain. It goes onto a nitrogen, and then you've got 2 branches off that where it might be like a CH2 and then an oxygen, and that's like a repeating set. And that's true across both of these chains. So I would suggest that this part of the molecule is probably some kind of friction modifier. But I'm not, a formulator, and so I don't exactly know how those products work. All right, so overall at the moment, from the, if you like, publicly available information, we can't really tell all that much about this product, to be honest. So I really want to understand more about this MFT technology. And funnily enough, if you go looking for it on the internet, the only real document that I could find, which was, let's say, worthwhile, actually came from Oil Club in Russia, where someone had published a bit of a document on how the product is supposed to work. Let's go across to that. So increased performance through reduced wear, yada, okay. These additive packages were launched under the name Microflux Trans and TGOA. So they're supposed to improve the surface quality without depositing or removing material. So that seems to contradict what we just learned about the product, where it said that it reacts with the surface. So that would suggest that it is, at the very least, they're having to deposit themselves on the surface. I don't quite understand what they're explaining here. The stress surface is smooth in the micro range by an almost non-sacrificial. Okay, so there is going to be a little bit of wear. Physical chemical 3-stage reaction with micro smoothing. So here's where they explain how it works. Basically, what they're trying to say is that whatever this additive is, and again, they're not really explaining how this works, it deposits itself on the surface, and then slowly, under increasing load, that layer gets compressed. And then when the surface plastically deforms, it basically smushes the peaks into the valleys. So if I had to draw that, what it's saying is that if I have some kind of like surface asperities like this, what it's saying is that if this here was a peak, whatever this additive is, when I place a compressive stress on this peak, the material from this peak plastically deforms and makes its way into the adjacent valley, is effectively how it happens. And so what you then get is like a smoothing of the surface, right? So there's no loss of material overall. the material just moves around on the surface. Now, on the face of that, if that is exactly how the product works, then that's fantastic. If you could get micro smoothing of the surface. It's just never really adequately explained how it actually happens. Okay, they've got some, actually, if I go back to it, they do have some, they've got some pictures or some case studies about exactly how that happens. And you do see some improvement actually in the gear teeth. Here in picture 1, up the top, they're showing something which definitely has, I would say, macro pitting at basically across the entire gear tooth. And supposedly after using this Castrol product, you end up with a much smoother image in picture 2. If this is real world scenarios, then it looks like it does the job. I'm just not entirely sure that they have explained how to. And this is, again, one of those complaints that I have, is that in the industrial world, we're selling these products to engineers, and engineers want to understand how something works without like the hand waving and the magic. They want to understand the mechanism by which these products actually work. And so I think there's a bit of a step change that our industry could make in helping to explain some of these mechanisms in a little bit more detail. So if anyone from Castrol wants to maybe come on the show and explain exactly how this MFT technology works, then I would be all ears. Anyway, this might have bored the pants off people. Please let me know in the comments if you found this useful. This is how I would go about evaluating a product if looking at purchasing it. Again, if you've got questions or comments, please leave them down in the comment section below. Otherwise, it's been Lubrication Explained.